Okay, welcome back to Mrs. Riley's Maths videos, and this is a video for my transition years, but it might be useful for anybody studying linear functions or linear equations and their graphs or coordinate geometry or anything like that. So here we have two questions based on graphs, and you're being asked to interpret the graphs and provide this information. So what I'm going to do is just talk this through. I'll hopefully be able to write in enough information on the questions so that you can follow what's happening. Okay, so this first question says the given diagram shows the graphs of two lines. So what we have here in the original book, they were in different colors, but just for now, so this is the line f of x equals x plus 1, that's that line, and this is the line g of x is equal to 2x minus 2. So the first thing to notice is it's an x to the power of 1. It's not an x to the power of 2 or an x to the power of 3. So an x to the power of 1 is a line, an x to the power of 1 is a line. Okay, write down the point of intersection of the two lines. So that's straightforward. Looking at my graph, what's the point of intersection? It's this point here where the two lines meet, and that's at the point 3, 4. So 3, 4. What is the meaning of the equation f of x equals g of x? And what it means is the solution is the same to both. So let's see, part 2 over here. The meaning of the equation f of x equals g of x in this situation means the same solution, which in the case of a graph is the point of intersection. So what they're basically checking is that you know that f of x equals g of x, which is the point of intersection of the two lines, means that the x value 3 and the y value 4 are the same on each line. So it's the point they have in common. Point in common on the equations, on the functions. Solve the equation x plus 1 equals 2x minus 2. So x plus 1 is equal to 2x minus 2. I'm going to subtract x from this side and x from this side, so 1 is equal to x minus 2, and add 2 to both sides, so x is equal to 3. So x is equal to 3 is the solution to that. Is there any connection between the value you found for x and the point of intersection? Yes, the same, x equals 3. So in other words, by solving the equations here, x plus 1 equals 2x minus 2, by solving those, then I am saying that I'm finding the point of intersection of the two lines. Is there another way of finding the point of intersection? Yes, hopefully you know it would be simultaneous equations. Simultaneous equations. In other words, we'd say y is equal to x plus 1 and y is equal to 2x minus 2 and solve them. If f of k has the same value as g of k, write down the value of k. So f of k is equal to k plus 1, g of k is equal to 2k minus 2. If they have the same value, it means they equal, so k plus 1 is equal to 2k minus 2. But isn't that the equation we've just solved? So k must be 3 for that. Okay, just instead of x, we've got k. Okay, on to question 12. The lines y equals x plus 2, which is this one, y equals minus x plus 2, which is this one, and y equals 2x plus 2, which equals this one. Those are the three lines. How are the lines similar? Well, I guess they're similar because they all contain the same point, which is this point of intersection, 0, 2. How are the linear equations similar? Y equals x plus 2, y equals minus x plus 2, and y is equal to 2x plus 2. Well, for me, the similarity there is those. So they all have a constant equals 2. In other words, a constant is a part of an expression that doesn't have an x or a y. So the constant is 2. And if you remember from your coordinate geometry, that means the y-intercept is 2. In other words, each of those lines cuts the y-axis at 0, 2, which is what we found out here. Remember 0, 2, that's the y-intercept of each line. How are the lines different? The lines are different because they have different slopes, don't they? This is quite steep positive, this is a less steep positive, and this is a less steep negative. They have different slopes. And part 4, the linear equations are different. Well, let's compare them. We've got y is equal to x plus 2, y is equal to minus x plus 2, and y is equal to 2x plus 2. So I think the difference here is this, isn't it? So let's see, that is 1x plus 2, that is minus 1x plus 2, and that is 2x plus 2. So these are the differences, that 1, that minus 1, and that 2. So x has a different coefficient. Now if you remember, if we go back to our coordinate geometry, y equals mx plus c, that's the form that these are in. So if you note, this one had a slope of 1, wouldn't it? This has a slope of minus 1, and this has a slope of 2. So from the equation we can tell the slope, and looking at that we can see also what their slopes would be. How would we do that? We do rise over run, I guess. So this black line here goes down 2 and across 2, so that would be minus 2 over 2, which would be minus 1. This line here goes across, goes up 2 and across 1, so this line here has a slope of 2. And this one here, let's take 2 points here, it goes down 2 and across 2, so it has a slope of minus 1, which is what we found. Okay, I hope that's useful, and just the different information we can get from linear graphs and linear equations.